Welcome back to our class in mechanics. So in today's video, or today's class rather, is a continuation of our previous class video. In our previous class, we did mechanics and we didn't finish the class. Okay, so in this video, I'll be teaching you guys how to do some calculations on mechanics. In the previous video, I only did one calculation. So in today's class video, I'll be doing more than 4 or 5 calculations. So let's start with the very first calculation, which is question 2. Okay. Now, in this question, I said, suppose that John runs along a cycle of radius 100 meter in 50 seconds. What is his average speed? Okay. So in this question, they are telling us to calculate for what? For the average speed. Okay. Now, what is speed? Speed is what? Speed is what? Distance of an is the distance covered by an object divided by what? Divided by what? Divided by the time, right? So suppose that John runs along a cycle of what? Radius 100 meter in 50 seconds. What is his average speed? Okay. So remember, what is speed? Speed is what? Distance over time. And in this question, they didn't give us distance directly. Okay. They didn't give us distance directly. So we have to look for the distance first before we can solve for what? Solve for the speed. Okay. So now if you look at it, suppose that John runs along what? John runs along a cycle. Okay. John runs along a cycle of radius what? Of radius 100 meter in what? In 50 seconds. So it takes 50 seconds for John to run around the cycle of what? Of radius 100 meter. Okay. And they are telling us that is in 50 seconds, and they are telling us to calculate for what? To calculate for the average speed. Okay. So how are we going to do this? In this question, they only gave us radius. They didn't give us distance. Now we are going to use this radius to look for distance. Once we get distance, we divide it with the time given, which is 50 seconds. We have our what? We have our speed. Now remember the distance of a cycle, or you can say this the circumference. Remember the circumference of a cycle, which is the distance rather. The distance of a cycle or the circumference of a cycle is equals to what? Is equals to 2 pi r. And if you understand, the circumference of a cycle, the whole distance of a cycle is equals to what? Is equals to 2 pi r. So in the place of this distance, we put what? We put 2 pi r. Okay. The whole distance of a cycle, the whole distance or the whole circumference of a cycle is equals to what? 2 pi r. Okay. Now let's continue. Which should be equals to what? 2 times pi is what? 3.142. Then times what? Times r, which is what? The radius, which is 100. Okay. So divide by what? Divide by 50. So let's calculate it. Okay. So 2 times 3.142, then times 100. Okay, I'm coming. 2 times 3.142 times 100, then divided by 50. Okay, so our total answer is 12.568. Okay, so the average speed is equal to what? 12.568. Okay, meter per second. So this is this average speed. Remember, what is average speed? Average speed of a body is what? Is the total distance covered by that body. Total distance covered by that body divided by what? The time. Okay, so this is the answer of this question. Okay, so let me just recapitulate everything. In this question, they didn't give us the distance directly, they gave us radius. Okay, then we use the radius to look for the distance. After getting the distance, we divided by what? By time. So let's move to the third question. The third question, and this question is quite tricky, but it's very easy. Now, a J5 bus traveling from Port Harcourt to Aba maintains an average speed of 100 km per hour. An average speed of what? An average speed of 100 km per hour. This is the speed. Okay, it left Port Harcourt at what? At 10 a.m. At 10 a.m. and arrived its destination at exactly 10:45 a.m. What distance was covered by the bus? Okay, so in this question is kind of like the previous one, okay, but it's just different scenarios. Okay, in this question they gave us the average speed, they gave us time, and they are telling us to calculate for the distance. I don't even understand. Okay, so which is easy. Remember, average speed is equals to what? Total distance, right? Average speed is equals to what? The total distance traveled by that body divided by what? Divided by the total time, right? Now in the question, they gave us speed, they gave us time. So we have to look for what? We have to look for it. We have to look what distance was covered by the bus. We have to look for what? The distance. Okay. Now let's go back to this point. 100 kilometers per hour. Remember, what is the SI unit for speed? The SI unit for speed is what? Is meter per seconds, okay? And we are not expected to solve using kilometer per hour. I don't know if you understand. Now, this is where conversion factor, conversion factor comes in place. I don't know if you understand. We will need to convert what? Okay. The speed that they give us is in what? Is 100 kilometer then per hour, okay? And we are not going to use this to solve, because if we use this to solve, we will not get our answer, okay? We will not get our answer. So what are we going to do? We need to what? Convert this kilometer per hour to what? To meter per seconds, okay? Which is very easy. Remember, according to conversion factor, remember, how do we convert from one unit to another unit? Now, so in something like this 100 kilometer per hour, we want to convert 100 kilometer per hour to what? To meter per seconds before we can use it to solve. Now, this 100 kilometer per hour is still the same thing as what? It's still the same thing as 100 kilometer dividing what? Dividing 1 hour, okay? If 100 kilometer divide 1 hour, it will still give us what? 100 kilometer per hour, okay? So on this, that is 100 kilometer divided by what? 1 hour. So we have to convert from what? 100 kilometer to what? To meter. Then from hour to what? To seconds. Once we get the two value, we divide. We get our final answer, okay? We get our final answer as the velocity, okay? We are looking for a distance, okay? So let's continue, okay? Now come in. Okay, so now remember, according to conversion factor, 1 kilometer is equals to how many meter? Is equals to what? 1,000 meter, right? So if 1 kilometer is equals to 1,000 meter, then 100 kilometer will equals to what? An S meter, right? Yes, because we want to convert from kilometer to what? To meter. I've taught this in our previous video under conversion factor, okay? So that is very easy. So we just cross multiply. 1 times S will give us S, then 1,000 times 100 will not give us what? Give us 100,000. Okay, so this is what? This is our answer. We have successfully converted from where? From kilometer to what? To meter. Now let's convert from what? From 1 hour to what? Seconds. Remember, 1 hour, according to conversion factor in our previous class, 1 hour is the same thing as what? It's setting as what? 3,600 seconds, okay? Remember, I told you guys that one. 1 hour is the same thing as what? 3,600 seconds, okay? So and we have successfully converted from kilometer to meter, then from hour to what? Seconds, okay? Now after we have gotten, after I told you guys that after we have gotten the two values, we divide them, abi? Yeah, so we have 100,000 meter, then divided by what? 3,600, okay? So if we divide, let's divide the answer. Let's divide it. 100,000 divided by what? 3,600. So if we divide everything, we have 27.77777, okay? So when we divided everything, we got what? 27.7777 meter per second. So we have successfully converted from what? From 100 kilometer per hour, from kilometer per hour to meter per second. Okay, we have successfully converted 100 kilometer per hour to what? meter per second. 100 kilometer per hour is still same as what? 27.7777 kilo, 27.777 meter per seconds. Okay, so we have successfully converted to what? To meter per seconds. Now let's continue. So we have converted this to what? We have converted kilometer per hour to what? To meter per seconds, right? Yes, but we are not done yet. Okay, so our speed is what? Our speed is now what? Is now 27.777 equals to, we are looking for what? The total distance. Let's take it as S. Now, another place that is quite tricky is this place, okay? It's left Port Harcourt at 10 a.m. That is 10 o'clock, okay? And arrive its destination at exactly 10:48. That is 2 time, right? It left Port Harcourt at where? At 10 a.m. Then it arrived at its destination at what? 10:48. Okay. So what which time are we going to use? What is the actual time? I don't even understand. Now from 10 a.m. to 10:45, that is 48 minutes. To 10:48 rather, that is 48 minutes. I don't even understand. So the time here is what? The time it takes, because it left Port Harcourt at 10 a.m. and it arrived its destination at 10:48. That tells you that it takes the bus 48 minutes to get to what? To its destination. I don't even understand. From 10 o'clock to 10:48. If you do the math, you find out that it's 48 minutes. Okay, so the time it takes it to reach its destination is what? Is 48 minutes. Okay, and we are not going to use this 48 minutes to solve. We'll do what? We need to convert it to what? To seconds. Okay, so we are converting this 48 minutes to what? To seconds, right? So remember, according to conversion factor, we all know this one. According to conversion factor, we all know that 1 minute, or we can say, okay, we all know that 60 seconds is equals to how many minutes? Is equals to what? 1 minute, right? Yes. So an S second will be equals to what? 48 minutes, right? So if we cross multiply 48 times 60, 48 times 60 will give us 2,880. So 2,880 seconds. So 2,880 seconds. Okay. So we have successfully converted from here, from minutes to what? To seconds. Now once we have gotten the actual speed, we have gotten the actual time. It's just for us to cross multiply. Okay. If we cross multiply, if we do the math, 2,880 then times what? Times 27.777. Okay, so this is our final answer, which is what? Our final answer is 79997.76 meter. Okay, so what distance was covered by the bus? So this distance covered by what? This distance covered by the bus. That is in meter. Okay, so this is the answer. Okay, this is the answer to this question. Okay, so in summary to this question, we were asked to calculate for what? To calculate for the distance it takes a bus to move from Port Harcourt to Aba. Okay, the bus was moving with an average speed of 10 kilometer per hour. So we converted from that 10 kilometer per hour to meter per seconds. Then the time it takes the bus to arrive to its destination was what? Was 10. The bus left Port Harcourt by 10 a.m. and it arrived to its destination at what? At 10:48. So that is 48 minutes. We converted from 48 minutes to seconds. Then we multiply our answer. We multiply our values to get our answer. Okay. So move to this fourth question. Move to the fourth question. Okay. So in the fourth question, the displacement of a body in the positive x direction is what? Okay, let me write it here. Okay, so they said the displacement of a body is y is 3. Okay, let me write it. Okay, Then, okay, so they said this is the displacement of a body in positive s direction. Calculate the velocity and acceleration after what? After 0.5 seconds. The time is what? Is 0.5 seconds. Okay. Now they are telling us to calculate for what? To calculate for the velocity and to calculate for the acceleration of, okay, yeah, of the body. Now this type of calculation is way different from the rest. This calculation is under instantaneous velocity as well as instantaneous acceleration. Okay. So to solve questions under this, we are going to use calculus using yeah, we are going to use calculus, specifically derivative, that is differentiation under calculus, specifically the power rule. Okay, so we have to differentiate. It's very easy. We have to differentiate this value. We are going to, because we have to look for two things. We are asked to calculate for what? To calculate for the velocity as well as calculate for the acceleration. Okay, this is instantaneous velocity, this is instantaneous acceleration. And to calculate for this velocity and acceleration, we are going to use what? We have to use calculus. Okay, yes, that is differentiation in calculus. Okay, so which is very easy. So the very first thing we are going to do is to differentiate this value. Once you differentiate the value, we impute time in this place. After imputing time in this place, we get our velocity. Let me just do it. Okay, now take note. To look for velocity, and please take note, it's very important. To look for velocity, we differentiate how many times? We differentiate one times. Okay, yes. To look for what? To look for velocity, we differentiate one times. I'll teach you guys how to differentiate for those that don't know how to differentiate. Okay, then to look for the acceleration, we differentiate what? Two times. Okay, yes, we differentiate what? Two times. Okay, so let's start now. Remember, the time is 0.5 seconds. Now, if you want to differentiate, now in calculus, if you want to differentiate, like there are different rules under differentiation or derivatives in calculus. We have product rule, we have the chain rule, we have power rule, we have like there are many. Okay, this is not mass. Okay, so this type in this type of scenario, this we are going to use power rule in calculus. Okay, we are going to use power rule. Now let me teach you guys how to use power rule. Okay, now let me say in the part now, let's say if they ask you to differentiate something like this, 5x raised to power 4, for example, this is power rule. Okay, because if you add one that is this question is coming from power rule, is because look at the powers here. Okay, so how are we going to differentiate? This is how to differentiate using power rule. Okay, so you will multiply the power with the coefficient of x. I don't even understand. You multiply the power. I'll give you guys two notes like to take under this part. Okay, two important notes. Okay, so how to look at power, how to differentiate using power rule. You will multiply the coefficient with the power, multiply equation with the power, then you also subtract one from the power. I don't even understand. So how are we going to do this? We multiply what? This is the coefficient of s, right? This is s, which is the variable. We multiply what? The power with what? With 5, which is the coefficient of what? X. 5 is the coefficient of what? X. So let's multiply the power with 5. So now be 5 times what? Okay, I'm coming. 5, let me see. Oh my god, my marker. 5 times what? 5 times 4, then x, then we do what? We subtract what? Subtract 1 from what? The power. So 5 times 4 will be what? Will be 20. Then 4 minus 1 will be what? Will be 3. So this is how you can, this is how to differentiate using power rule. So this is how to differentiate using power rule. Multiply the power with the coefficient of x, then subtract 1 from the power. So this is how to differentiate. Okay, now I told you guys I'll tell you guys two things. Okay, so this is how to differentiate. Another thing, that is, this is how to differentiate using power rule. Okay, and another thing, if the value is not it does not have a variable, like for example does not have let's say it does not have a letter. Let's say if I'm standing alone and they tell you to differentiate this, to look for to take the derivative of a value that does not has a variable or a value standing alone is 0. I don't even understand. So when a value is just standing on its own, like x is not attached to it, or any letter or any variable is not attached to it, the derivative or the differentiation of that value usually was 0. Okay, so let's say for example they tell us to differentiate 5 to what, to be 0. Okay, so that is how to do it. Okay, so now let's do it. Remember, I told you guys that to look for what, to look for velocity, what do we do? What we will differentiate 1 times. Then to look for acceleration, we will do what, we differentiate 2 times. Okay, so now I've taught you guys how to differentiate using power rule. So multiply 4 with what, 3 times 4, right? Multiply the power time with the coefficient, then times t. We subtract 1 from the power, right? 4 minus 1, right? Then plus 2 times 3 times t, then subtract 1 from the power, 3 minus 1, right? Then plus what? 4 times 2 times t, subtract 1 from the power, right? Yes. Then plus what? Now, 5t. Now, 5t means that, oh, there's 1 here. T standing alone means that it's the same as 3 raised to power 1, right? So, 5 will multiply in what? 5 will multiply in 1, right? Which is the power. Then times t. Then we know that t has 0 to the power 1, right? Minus 1. We know that one, right? Minus 1 from the power, okay? So, let's do it. 3 times 4, that is 12. Times t, that is 12t. 4 minus 1 will give us 3, right? Then plus 2 times 3 is 6. Times t, then 3 minus 1 give us 2. Then plus 4 times 2, that is 8. Then t, 2 minus 1 give us 1. So to now be 8t1, which is certain as what? 8t, right? Yes. Now 5 times 1 plus 5 times 1 give us 5. Then times t give us t. Then 1 minus 1 will give us 0. So t will be raised by what? 0. Remember, according to math, anything raised to the power of 0 will give us 1. Abi? Yes. So this t will automatically turn to what? Will automatically turn to 1. So anything times 1 will give us that same thing, right? So okay, we have arrived in something like this, right? Yes. So now we have to look for what? We have to look for what? We have to look for we have differentiate. Remember, I told you guys we differentiate what? We differentiate to look for the velocity, we differentiate 1 times. Yes. Now we have differentiated 1 times, right? Yes. Now what is the time they gave us? They gave us that time is what? The time is 0.5, right? So we have to input 0.5 in this place. I don't even understand. So let's do it. Now be 12. 12. I'm coming. Oh my god. Okay, so it's now be 12. T, remember t is what? 0.5, right? 0.5 all raised power of 3, right? Then plus 6 bracket open, t is what? 0.5 all raised power of 2, then plus 8 bracket open, 0.5, abi? Yes, then plus 5, right? Yes. So let's do the calculation. Now be 12 bracket open, 0.5 bracket close, raised power what? 3. Then let's continue, plus 6 bracket open, 0.5 bracket close, raised power what? 2. Then plus 8 bracket open, 0.5 bracket close, then plus 5. So if we do everything, we get what? We get 12 meter per second. So our velocity is what? Our velocity is what? 12 meter per seconds. Okay. So that is very easy. Okay. So whenever you see question like this, and I tell you this question is under Satinus acceleration, Satinus velocity. To calculate for the velocity acceleration, we use what? We use calculus. Specifically, so in question like this, we use what? Power rule. Okay. Now, what about the acceleration? We have gotten our velocity to be 12 meters per second, right? Yes. Now, what about the acceleration? Remember, I told you guys that to look for the acceleration, we need to do what? We need to differentiate 2 times, right? Now, when we're looking for the velocity, differentiate 1 times, right? We differentiate this value. Okay, this is the value, right? So we differentiated it 1 times. That is for velocity. Okay, we got this something like this. This was when we differentiate velocity. When we differentiate it 1 times, we got this, right? So we have to differentiate this one again, making let's say that we have differentiated 2 times. I don't even understand. We differentiated from here to here. That is 1. Abi, we are going to differentiate this one again because we are looking for what? Acceleration. Remember, I told you guys that to look for the acceleration, we need to differentiate what? 2 times. I don't even understand. Okay, so let's differentiate this one again. I've taught you guys how to differentiate. Okay, so this one will do what? How to differentiate using power rule. Multiply the power with the coefficient, then subtract 1 from the power, right? So now be what? 12 times what? So now be I'm coming. Now be 12 times 3. 12 times 3. Okay, then times t. Remember, we'll subtract 1 from the power, right? So 3 minus 1. 3 minus 1, okay? Then, okay, so I'm coming. So, okay. So 3 minus 1, then plus 6 times 2. 6 times 2 times t. Subtract 1 from the power, 2 minus 1, right? Then plus what? 8 times t. Okay, no. Now, remember, 8t still means what? 8t raised to power 1, right? Yes. So it now be what? 8 times 1, right? 8 times 1 times t raised to power 1 minus, the power is 1, right? So subtract 1 from 1. Then plus, what about 5? Remember, I told you guys that when a value it does not take a variable, to look at the differentiation or the derivative of that value will be 0, because 5 doesn't take a variable. Do you see t here? No. So to differentiate this value to give us 0. So differentiating 5 here will give us 0. Okay. So let's continue. Okay. So 12 times 3. 12 times 3, that is 36. Okay, so that is 36. So that be 36 t raised to power 3 minus 1, 2, right? Then plus 6 times 2, that is 12. Then raised to power 2 minus 1, that is 1. Okay, so 12 t raised to power 1 is the same as 12 t. Okay, then plus what? 8 times 1 times 2 give us 8 t. Then remember, 1 minus 1 give us 0. So 8 raised to power 0 give you 1. So 8 times 1 still give us 8 times 1 still give us 8. Okay, so we have arrived in this place, right? So what have we done so far? Remember, I told you guys to look for their solution, we need to differentiate 2 times. We differentiated from this to this, 1. Then we differentiate from this to this, 2. Okay, so what next? We have to input what the value into of t of time into this place. Okay, so now be what? 36 bracket open 0.5 bracket close plus what? 12 bracket open 0.5 bracket close, then plus 8. Okay, so if we do everything, let's multiply it. 36 times 0.5 give us 18. Then plus 0.5 times 12 give us 6. Then plus 8. So let's add everything. Okay, so I'm coming. Okay, 6 plus 18, then plus 8. I mean, yeah, 18 plus 6 plus 8 will give us 32. So the acceleration is what? Is 32 meter per seconds. Okay, meter per second square. Okay, so this is the acceleration, this is the velocity. So that is how to solve. Whenever I see any question like this, it's very easy. If they tell you to calculate the velocity, differentiate it once. I've taught you guys how to differentiate. Then for the acceleration, differentiate 2 times. After differentiated, you just need to add the value of t, to add the values to t. Then do the math, you get your answer. Okay, so let's do other questions. So looking at this question is like the previous one we did just now. The displacement of a body in positive s direction is given to be what? S equals to what? 3t cube plus 2t square plus 4t then plus 5. So the time, find the velocity acceleration after 5 seconds. Okay, so the time is what? The time is 5 seconds. Okay, it's just like the one you just did just now. Okay, so what are we going to do? That just to since they told us to look for what? The velocity, and they told us to look for what? The acceleration. What are we going to do? Look for the velocity, we differentiate 1 times. To look for the acceleration, differentiate 2 times. Okay, so let's differentiate. I've told you guys how to differentiate. Okay, so now be what? Now be 3 times what? 3 times t, 3 minus 1, then plus 2 times 2 times t, 2 minus 1, then plus what? T raised to power t standing alone is still sent as t raised to power 1. So that be 4 times 1 times t raised to power, okay, 1 minus 1, right? Then now I told you guys, when a value standing alone does not have a variable, the differentiation of that value give you 0. So differentiating 5 will give us 0. Okay, so and let's do this. 3 times 3 will give us 9. Then times t. Then 3 minus 1 give us 2. Okay, then plus what? 2 times 2, 4. Then times t, 2 minus 1 give us 1. Abi? Then 4 times 1 give us 4. Times t, 4t. Now 1 minus 1 give us 0. So 0, anything plus 0 give us 1. So all here is what? 4. Now, this one is still sent in as what? 4t. 4t raised to power 1 is still same as 4t. Okay, so now what are we going to do next? And to input the value of time inside there, right? So now be what? 9 times what? Times 5 square, then plus 4 times what? Times, okay. Okay, let me just do it like this, okay. So 9 brackets, 5 square, then plus what? 4 brackets what? 5 square, then plus what? 4. Okay, so then you square. The square of 5 is 25. Okay, so 9 times 25 will give us 225. Okay, so give us 225. 225, then plus 4 times 5 is 20, then plus 4. If we add everything, 20, then plus 4. We add everything, give us 249. So our velocity is what? Is 249 meter per second. So this is our velocity. Now worry about our acceleration. Okay, it's very easy. Now remember, to the guys that look for the acceleration, this was our first derivation, abi? Yes. So to look for acceleration, we differentiate this one again. Okay, so if we differentiate this, 9 times 2. 9 times 2, then times t, minus subtract 1 from 2, right? Then plus what? Then plus 4 times t raised power t has 1, abi? Yeah, so anything standing alone, since something as well, starting raised power 1. So this is something as this. I'm coming. Okay. Okay, 1. So 4 times 1, then oh my god, no marker again. Okay, so now be 4 times 1, 4 times 1 times t, then 1 minus 1, right? Then plus differentiation. If you are differentiating a value on its own, that's a variable, it give us 0. So differentiating 4 will be 0. So let's continue. So 9 times 2 is 18. Then times t to the 18t. 2 minus 1 give us 1, right? Then plus what? Plus 4 times 1, that will give us 4 times t, 4t. Now 1 minus 1 give us 0. So t raised power 0 will give us 1. 4 times 1 will give us 4. Okay, so here will be 4. Then here will be 18 t raised power 1, which is setting as what? 18t. So remember, the time is what? The time is 5 seconds. So just let's input 5 in this place. That be 18 bracket 2.5 bracket close plus 4. So 18 times 5 give us 90, then plus 4. So 94. So our acceleration is what? The acceleration is what? 94 meter per second squared. So this is the answer. So this is how you can solve question under instantaneous velocity, under instantaneous acceleration, using differentiation and all. Okay.